Hi, this video is meant for 0606 IGCSE Additional Mathematics. In today's video, I'll be teaching you guys how to find the domain and range of a function, finding the inverse of a function, and how to solve composite functions for certain values. I'm Nathan, and today we're going to run through these three criteria while solving past year questions. The first question we have here gives us the function fx is equal to 2 minus sert x plus 5, and they have given us this domain. Our first question has asked us to write down the range of f. So let's begin by writing our function. This is just rewriting from the question above. Alright, now we have two values for the domain here, and how we're going to find the range is by plugging in these values. So let's start with negative 5. So the function of negative 5, in this case we replace the x with a negative 5, is equal to 2 minus sert, and in this scenario our x is also substituted, so we open brackets here, substitute in a negative 5 and plus the 5, and this will give us 2. Now negative 5 plus 5 is just 0, and sert 0 is just 0, so this is just a 2 minus 0 function of negative 5. And we find out that when negative 5 is inserted into the function of x using this function, we get an answer of 2. So this is our first value. However, we still have to do this again with the second value of 0. So substitute in 0 here. Function of 0 is equal to 2 minus sert 0 plus 5. Now this simplifies easily to just 2 minus sert 5, and we can just leave it in this form for now. Okay, so now we have these two values. So this is our first value, this is our second value. It doesn't really matter, it can be anyway. So now you'll be asking, okay, are we done here? And we're not, because we have to write this in the range form, right? So this is for domain up here, and we have to write this in range now. So you'll be asking, how are we going to do that? So range is actually considered to be the y value from the function of x. So when x is inserted into the function of fx, that is what we get back as the range. So we can begin by writing fx. Fx just means y, right? Fx, so then we put our two signs here. We can just copy from above. And obviously we have to choose the smaller value to be on the left and the larger value to be on the right. So obviously 2 minus sert 5 is the smaller value and 2 is the larger value, so we can just put it like this. However, we're not done yet, because as you can see here, our bigger than sign actually also has an equal to. So you may be thinking, oh, in that case, why can't we just write our equal to here? But this is actually wrong, because you must pay attention to the value of x, which has actually given us this equal than, which is actually negative 5. And you can see here, when we've substituted negative 5 inside, our value is actually 2. So the equal than sign should actually be here. And this is our final answer. Alright, next part. Now we have to find the inverse, so f power negative 1x just stands for the inverse of the function, and state is domain and range. Alright, so let's begin by finding the inverse function. So let's rewrite our original function. Function of x is equal to 2 minus x plus 5. Alright, so as stated earlier, we can actually convert function of x into y. 2 minus x plus 5. Alright, so now the method I'm going to be using today is where we're going to change the x for y and change the y's into x's, and then we have to make y the subject again. What do I mean by this? Alright, let me show you. So this y turns into an x, 2 minus sert, and this x actually becomes a y here, y plus 5. Alright, what can we do now is we actually have to make y the subject again in order to find our inverse. So this is relatively simple. So negative sert y plus 5 is equal to x minus 2. This is just a simple rearrangement. We've just moved the 2 to the other side. And now what we can do, because we don't want to deal with a negative square root at the front here, our next line, we can turn this positive. We can flip the whole system of equations, make this a positive square root, turn the x negative, and make the 2 into a positive 2. You can rewrite this as 2 minus x. Now when you move the square root to the other side, it's just a square. So y plus 5 is equal to 2 minus x squared. And finally, you move the 5 over to end up with 2 minus x squared minus 5. And finally, don't forget you have to convert your y back into f inverse. Now this is your inverse function. However, our question has also asked us to state the domain and range of this function. Now you may be asking, how can we find this domain and range of the inverse function, right? What we can do here, one property of inverse functions and functions themselves. So let me draw a table out here. Function. This is the normal function, and this is your inverse function. So the domain of a normal function is actually the same as the range of an inverse function, and the range of a normal function is the same as the domain of an inverse function. Now, knowing this, we have already calculated the range and domain of the previous equation, or this equation here. So our domain has been given as -5, x, and 0, and we can just actually directly copy this as, and we can take that as our range. So our range we put here, and for domain we don't actually have to write as an inverse because domain is just our x values, right? X, and we can just copy the same range from above here. So alright, my apologies if it's messy, but these two are your final answers. There you go. And this is your, down here, this is your inverse function. Alright, let's move on. The function g is defined by gx is equal to 4 over x for this domain. Alright, so this is our domain. Solve f(gx) is equal to 0. So this right here is actually a composite function. This is our composite function. Okay, so what exactly does the question mean by f(gx)? Now the function which is closest to the x is actually the function which is going to be placed into another function. What do I mean by this? Okay, first of all, let's recopy down our function of x. What is our function of x? Scroll up. Is equal to 2 minus x plus 5. Alright, okay. And gx is equal to 4 over x. So because when we're solving for f(gx), g is actually the closest to x. So what this actually means is that we have to put gx into fx. So let's take our fx. So f gx is equal to 2 minus, now instead of copying down x here, you can see the x is here. Instead of copying down x here, we actually use this value of 4 over x instead. 4 over x, and then we can copy as normal. So it's just plus 5. Now this one is relatively simple, but you can understand the concept just from this simple substitution. Alright, now we have to find this as equal to 0. So what we can do here is 2 minus 4 over x plus 5 is equal to 0, and then we can solve this as a normal equation. So let's bring the 2 across first. So negative sert 4 over x plus 5 equals to -2, and we can make everything positive. Okay, we bring the square root over. 2 squared is just 4. 4 over x is equal to -1. And now what we can do here is 4 over -1 is equal to x. And so we have -4 is equal to x. Alright. Now we have to check back into our domain here. So -4 does fit the needs of our domain, so this answer is considered as correct. x is equal to -4. This is your final answer. Alright, let's move on to our next question. So this is our second question, and it's quite similar to our first question. This is also a function, however this is a exponential function, right? Because this e is powered to -4x, oh sorry, I mean this 3e is powered to -4x, and there's a back here, plus 5. This is our constant value. So for our first question, it's asking us to state the range of f, but our domain is XER, which is basically all real numbers for the domain, right? So you may be asking, well, we don't have any values to substitute in now, so what can we do about this? So this graph, the graph of 3e powered to -4x, probably looks something like this, right? However, the plus 5 at the back may actually make the graph look something more like this. So this is an asymptote line. This is y equals to 5. And the graph is actually elevated. So what can we take away from this? Well, if you can notice one thing, is that the graph will never go below the line y is equal to 5, because this standard graph is actually raised 5 units on the y-axis. So our answer is actually really simple. It's just that the range of f is that y can never be greater than 5, simply because the whole equation, no matter what x is, no matter what it powers to, or how small the 0.0000 is, at the end of the day, the plus 5 is still being added to that final value to get the final value. So the range of f is simply just function of x is larger than 5. Oftentimes, these domain questions will ask simple 1-mark questions, and stating the range of a function, if it's just 1 mark, don't overthink it. It's most likely really easy. So our second part here, find f inverse and state its domain. So the first thing I like to do is always rewrite the initial function. This makes it easier to refer to. This is just reference. Okay, now we're going to turn the function of x as a y, treat it as y, rewrite plus 5. Okay, now we're going to swap the positions of x. Oh sorry, we're going to turn every single y into an x and turn every single x into a y. Okay, so now we need to make y the subject. So let's bring over the 5. It turns into a -5. Okay, and what we can do, we can also move this 3 across. So x minus 5 over 3 is equal to e power -4y. Alright, now what we can do here, this question actually involves the use of logarithms to solve this. And so when you're solving with logarithms, right, when you would like to add to both sides, there are a few logarithms you can choose from. You can just choose from a basic log. You can choose log. This LG actually stands for log with a base of 10. Or you can choose for the natural log, which has base e. Now, some form of theory here, right? So basic theory here is that log with base x and x here, like this, is actually just equal to 1. And knowing this, if you look at our current equation here, we actually have an e. So we're actually going to choose log with a base of e, or natural logarithm. So we can add that to both sides. So ln, remember to open brackets. Alright, so what we can do now, okay, we'll leave the left side alone first. And one property of logarithms is that our exponent can actually be brought down here. So like this, -4y, natural logarithm of e. Now natural logarithm of e actually can cancel itself out into 1, and -4y times 1 is just -4y, right? So we can just cut this out, because ln actually stands for log with a base of e, and what we have here is log with base of e and an e, so it can cancel itself out. So negative 4y is equal to natural logarithm x minus 5 over 3. And we can just actually rewrite this as y is equal to negative 1 over 4 times natural log x minus 5 over 3. Replace our y with an fx here, so erase, and we can replace this with fx, or f inverse x. Alright, now we just have to state its domain, and we actually have the range of our initial function of x, and using the properties of inverse functions, we know that the domain and range are actually equal. The domain of the inverse function is actually just the range of the original function. So now for the domain, using those properties, we can actually just copy this. However, domain, we do not have to put it as a function because domain is just an x value. So x value is larger than 5. That's it. So these two are our final answers. Alright, okay, that's the part 3 now. So let's try to solve this. It is given that gx is equal to x squared plus 5 and hx is equal to natural logarithm of x for x is larger than 0. Solve hgx is equal to 2. So first we have to define what hgx is. This is a composite function. So this means the function of gx being inside the function of h. So let's write h. So natural logarithm, hx is natural logarithm of x here, but instead of writing x, we'll actually substitute in for this for gx. So x squared plus 5. So now that we've defined what our composite function actually is, we're solving for the value of 2, right? From here, hgx is equal to 2. So what we're going to do now is we can actually bring this natural logarithm over, because its base is actually e, right? This is a logarithm with the base e, so it can be transferred over to be an e squared. So x squared is equal to e squared minus 5, and x is equal to plus minus e squared minus 5. Alright, so we key this into our calculator and we will get now set of e squared minus 5 is equal to 1.546. We also have plus minus for plus minus cert. However, remember our domain only accepts positive values, right? So we automatically can ignore this negative sign here, and we can just take x is equal to 1.546, or x is equal to cert e squared minus 5 as our final answer. Alright, that's it for this video. I hope you have learned something new today. If there's any doubts you'd like to clarify, please leave me a comment down below. I'd be really happy for your support to like and subscribe, and thank you for watching.